Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay back with yet another geometry video for you all. Today's lesson topic is all about congruent polygons and their corresponding parts. But before we jump into today's lesson, please make sure you smash that subscribe button down below, hit that like button on this video, as well as hitting that post notification bell to get notified on any of our channel's latest posts at eCoreAcademy. All of that is very greatly appreciated. Like I said, today's topic is all about congruent polygons and their corresponding parts in geometry, and the whole theme and purpose of today's lesson is to discover how do two polygons qualify as congruent, and how do you discover their congruent or corresponding parts, so their congruent corresponding parts. So today's video is going to be basically building and stemming off of our original topic that I referred to before in the beginning of our geometry course, which was all about congruent and similar figures. So we're going to focus on congruent polygons, and if you don't already know what polygons are, I've mentioned that before and you already expect to know that, but polygons are any shapes that are closed figures that have at least two straight sides that contain them. So, examples of that: triangles, squares, rectangles. They can go on n number of sides, meaning it's an infinite number of sides. So we're going to try and identify congruent polygons, and congruent polygons are basically polygons that have the same exact side lengths and the same exact angles. So they're identical polygons, and we're going to see how their corresponding parts have a relationship between each other. How do you identify these corresponding parts, and what relationships they actually entitle each other to? So let's jump right into it. Let's look at let's first identify what exactly congruent polygons are. This slide's focus basically all about congruent polygons. Let's see exactly what they are before we start determining and getting into higher case scenarios with them. So let's talk about polygon congruence, and let's just identify what congruent polygons are and under what postulate they actually fall under. And let's look at that right now. So the polygon congruence postulate. If you don't already know what a postulate is a form of a geometric law, and this is basically a formulation of a definition of congruent polygons. So basically, in essence, we're just looking at congruent polygons here. So the polygon congruence postulate states that polygons with the same corresponding side lengths and angles are said to be congruent. And what that's basically saying is it's showing a bit of a proof and a reasoning statement and a law that it must be followed. So it's saying that if two figures are congruent, like these triangles ABC and triangle DEF, if they are congruent, that means that their corresponding parts, including their side lengths and their angles, must be congruent. And congruent means of the same measure. And that means if these two shapes are congruent, doesn't necessarily mean that they're in the same location, but they have to be the same exact shape and size. So that's a bit of a simple definition right there. So let's start moving into our topic for today. So let's look at the process in which you can actually formulate this identification process, and how you can actually identify two congruent polygons and their corresponding parts, just as the title of this lesson suggests. So how to identify congruence between two different polygons. So when looking at two polygons, you will want to start looking in a clockwise direction to match up correspondingly congruent parts. So what that basically means is you're taking a figure, and after you look at that figure, it's going to be labeled with vertices and points, and all you're going to be doing is you're going to be looking in a clockwise direction outwards to see in which order those points occur. So you're starting from the leftmost point, and then you're working your way around like a clockwork. It's going to be all the way around that figure in a circular motion, and you're going to match up correspondingly congruent parts that are relative to your two different polygons that you're trying to compare and prove as congruent. And just note that they won't always have the same position, meaning your triangles won't necessarily have the same relative position. One might be rotated, one might be altered in comparison to the other one, but you're still going to try and calculate that those points all together, and then you can use later on these congruence relations that I will later state onwards, and the different tick marks and identification points to actually identify which one will follow which. So let's just revisit this here. I'm going to draw a little example here. So if we have triangle, I'll just draw out these two triangles. We'll assume that they're both congruent. So A, B, C. And D, E, F. me just outline these lines a bit more so that they look a bit more straight. Okay, when we're looking at these two triangles, let's just say that they are automatically congruent. Let's just assume that they are congruent triangles here. So what we're saying is that triangle ABC is congruent to triangle DEF here. And what we're going to basically do is identification of this triangle. How we actually name this triangle, you might be confused. Well, what arrangement would you put these points in without actually proving a congruency postulate, without using the congruency postulate? And you're looking at these two triangles. While looking at these two triangles, you can see that they both consist of a similar position. So since they have a similar position to each other, that means you do not have to follow the congruency postulate that I will later refer to. You can just simply use this clockwise direction format that I have given to you. So what you're going to do is you're going to look clockwise. So that's going this way, around, all the way around. You're going to identify the points of this triangle. So this triangle goes from B, the leftmost point, up to A, over to C. So that's triangle BAC. And then this is triangle DEF, so it's going from this way, starting from D, going to E, going to F, and then back to D. So that means that this is triangle DEF. And basically, these two triangles are congruent, signified by this sign right here. All right, so let's move on to a bit of a more complicated process. And these are the properties of corresponding parts. And this is just assuming that these two triangles are not going to be in the same relative positions, which most of the case, you're not going to be given such easy scenarios in this identification process. But don't worry, because we have these simple steps to follow. This is more of a step formulated lesson here, more steps rather than terms and definitions, because I've already given you those terms and basic terms and definitions in previous videos. So you're already assumed to know that, but now we're just going to be looking dead on into the process that this accumulates. So let's look at corresponding parts, what we're mainly here for in identifying congruent polygons. So two polygons are congruent if their corresponding sides and angles have the same measure, like I said before, and that's in units of their length and degrees. Degrees relating to the angle measures, and the length can be, units in centimeter in the customary system or the imperial system, as well as the metric system. Metric system is much more accurate, much more common, and it can be used in relation to all of those units. And yeah, so that's just saying that two polygons are congruent through those very properties, and we can actually prove even further that corresponding parts have some similarities as well. So tick marks and ellipses show congruent sides and angles. What that's saying is, after you've identified the two triangles are congruent, or if you want to identify whether or not two triangles are congruent, you can utilize the fact that tick marks and ellipses show that corresponding parts of congruent triangles are also congruent. So what I'm saying is, if you're given two triangles here, like say for example, I'm going to draw this triangle. Actually, let's draw a square here. I'm going to change this figure up a bit, get you used to different figures. So let's draw a square here. Let's assume that this is a square. And I'm not going to label the sides yet because that's not necessary to us, but I will just label these tick marks out. So this is 1, 1, 1, 1, that, and that. So I'll tell you what I'm doing after I draw this out here. So what I'm doing is I'm drawing these two separate squares, and we're going to assume that these two squares are congruent. And what I'm drawing is the tick marks and arcs / ellipses that I'm drawing here to actually signify that corresponding parts of congruent squares are congruent. So I'm going to just say that this is congruent. These two are congruent. Okay, so if we're looking at these two squares that I've drawn here, I did not identify the points because that is not a necessary step in this identification process, but I've already clarified that these are two congruent squares. If we look at these two squares, we can see how we have these 4 1/ tick marks, and you can see here this square also has those 4 1/ tick marks. That is because the 4 parts of a square are always the 4 sides of a square are always going to be congruent. So those tick marks basically show that whichever sides have one tick mark means that they're always going to be congruent to each other. So all the sides that have one tick mark on them are always going to be congruent. If it had two tick marks and one tick mark, the group with two tick marks would be congruent, and the group of segments with one tick mark will be congruent. So all the side lengths with one tick mark are considered to be congruent. And as you can see here, each one corresponds to its corresponding side since they're all congruent to each other. So that means all side lengths are congruent. And if you look at the angle measures here, since we know that squares all have four 90-degree angles here, they signify that by the square here. And that square actually represents, that semi-square actually represents a 90-degree angle. And as you can see here, it corresponds to its corresponding point and side, and their angles also correspond with their lengths as well. And that shows that each corresponding part of a congruent triangles are always going to be congruent. So all these side lengths will be congruent to their corresponding sides here, and their congruent corresponding angles as well. Properties of corresponding parts, part 2, and we're going to look at a bit more of an in-depth, a bit of a rule that comes with this whole qualification for corresponding and congruent polygons and their parts, corresponding parts. So this is corresponding parts continued. So don't worry about the displacement of the figures and only their tick marks and arcs. So that's very important. Like I said originally, you might not be always given a scenario. You might not always be given a scenario in which your two figures that you're trying to identify congruence between will actually be of the same position. Meaning, in relation, you'll have one triangle right here. Say, for example, this is the face of one triangle. It's going to be in the exact same position. Sometimes it's going to be altered, shifted, and displaced off of a lateral or horizontal line of symmetry, and that's going to be the case a lot of the times. But it does not matter the position of that triangle. All that matters is you're able to identify tick marks and arcs, and you're able to identify corresponding parts of these triangles or these shapes in general to identify whether or not they are congruent. And you can also represent these corresponding parts through equal measures. So what I'm saying here is you don't necessarily need arcs or tick marks, but all you need is exact measures. So if I were given a single triangle here, and if instead of points and labeling for my points, if I were given, say for example, 15 units squared, I'm going to say that, and 16 units squared, and 14 units squared. And then I'm given the degree measures for my angles, like so on and so forth. So I'm given degree measures 60 degrees, 64 degrees, and 70 degrees. All that will be applicable. So this is also a common way of proving that. And this is the most common way. This is something that you're already used to, something that you've already been acquainted with. But these tick marks and these arc measures are going to be related to geometry. They're very simple, and they're used for a bit of a shortened process. These simulations are very important to see because sometimes you're not necessarily able to write out such units and measures because they might be too complex or they might not fit within the figures relation. So it's very important to describe a simulation in geometry. So let's look at congruence relations. This is a very important part of this lesson here. We're going to actually see how we can identify congruence. So we're going to see a congruence identification, and this is specifically through corresponding parts, not through what's given to you. Oh, say for example, you're given a problem and you're automatically given, oh, these two triangles are congruent or these two squares are congruent. This is a bit of a reverb beyond that. We're going beyond this and behind this, basically behind the scenes. We're going to try and prove the problems that you're going to come across is prove that these two triangles or squares or figures, polygons are going to be congruent, and try and make a congruence relation statement. And I'll show you what that is. So a congruent relation or congruence relations are when you order the points on one polygon, the side lengths, meaning the side vertices of that polygon, by representing the side lengths and angle measures to each corresponding point on the other congruent polygon. So what that's basically saying is, I'll use a triangle as an example here, or let's use a rectangle here. So if I were to take a rectangle like this, we're not gonna, actually we will label that here, A, B, C, D, and I'm given another rectangle here. So we'll label this one W, X, Y, Z. So once we've drawn these two rectangles out, we'll label their points W, X, Y, and Z. So we're trying to find whether or not these two rectangles are congruent. So I'm going to draw a question mark there to see whether or not they are congruent. So in order to discover whether or not they are congruent, that means you have to have corresponding parts with equivalent measures. So what you're going to do is, what happens is you're going to see, say for example, let's assume that these two rectangles are, and we're just trying to prove that. We can see that, say for example, A, B, C, and D, they're all 90-degree angles, and they will correspond directly to whatever side, whatever point they are on this rectangle here, W, X, Y, Z. So we see that A in relation of position to W will be congruent to W, so that means A and AW will be congruent. So if we look at that here, A is congruent to W, that means it's showing the angle measure. So that means the angle measure will be congruent, and that's true because the angle measures of A and W are going to be congruent. However, you also need to prove side lengths. So what happens is you're looking at A here, correct? You want to find another corresponding part that forms a line with A, and that's either point B or point C. So let's look at point C. If we look at point C, the corresponding angle and position for angle C is actually angle Y, as you can see here in relation. Since A is congruent to W, that means C must be congruent to Y. So that means that AC is congruent to WY. And that's also true because if you look here, A is congruent to W, the angle measures are congruent, and C is also congruent to Y. But also, if you're looking here, if you're trying to say that the segment AC, if you're trying to say that points A and C form a segment, and that's segment AC, you're also saying that it's congruent to segment WY, and that is always true. Since both of those angle measures are congruent, that means they must also be congruent side lengths with those 2 points given. So that's a little example of what that is. And the whole entire congruence postulate would be A, C, D, B is congruent to W, Y, Z, X. And you can always reorder that, but make sure that these points correspond with each other, meaning A goes with W, C goes with Y, and etc. on and on and on. And finally, this is a little last slide of information, and then we're going to do one practice problem with these congruence relations. But I want to look at congruence relations as proof. So proof is very important in geometry, and you're trying to see how exactly does this whole entire concept that we've developed actually state and by geometry, and how does it prove that congruent polygons are congruent, and what form would we actually express that? So I'm just going to give you this form of proof that you can use, and it's saying that a proper reasoning for proof for congruence relations would be corresponding parts of congruent triangles or polygons in general. I put that in there because our next unit is going to be on triangles, but that can also be congruent polygons, and that's saying that they all are congruent. So corresponding parts of congruent polygons are congruent. So if you can identify if two polygons are congruent by the laws of geometry, then that means all of their corresponding parts, meaning their parts in relation in position to each other, are going to also be congruent. And you can also use that in reverse. So that means corresponding parts, you can discover whether or not a figure two polygons have corresponding parts, and that can prove the congruence between them. So that's a very basic concept. And finally, let's move on to our congruence relations practice. And I just have a simple problem here. So it's going to be writing a congruence relation for these two congruent triangles. So since we've already identified that these two triangles are congruent, we're going to be developing a congruence relation. If we didn't know that they were congruent, we can actually prove that by showing these tick marks here as shown here. But now we're going to go step further and try and develop a congruence relation. And in order to develop a congruence relation, you need to know whether or not the triangles are congruent. So we already know that these two triangles are congruent. Let's go ahead and develop our congruence relation. So if we're looking at these triangles right here, we're going to look at our little angles here. So we're going to start with our angle. So if we look at point A here, right here, we see that its angle measure has one arc here. So since it has one arc here, we're going to start and identify which angle on triangle DEF has one arc on it. And we can see here that angle D has one arc on it. So therefore, remember, our congruence postulate is going to be like 1, 2, 3 letters is congruent to 1, 2, 3 letters, since a triangle has 3 vertices. So that's what the form we're going to take here. So we're going to look and see that A is congruent to D. So we'll say that A is congruent to D. So that means A goes first, and D also goes first since they're both in the corresponding positions. And then next, we're going to look at which angle has, we're going to look at angle B on triangle ABC, and we see that it has the 90-degree angle, which is basically the semi-square. We're going to try and see which angle measure has the 90-degree angle on it with the semi-square, and we can see that point E or angle E has that qualification. So that means that B is going to be congruent to E, and that's in terms of the angles. And then finally, we see that C and F are left out, and since we know that they are congruent and they have double tick marks on their angles, if you don't see that, we know that C must also be congruent to F then. So C must be congruent to F. So let's just fill that in here. So B is congruent to E, and C is congruent to F. And we can also prove that by looking at the side lengths. We can see that this triple tick mark is going to be congruent to this triple tick mark because they have the same amount of tick marks. And as you can see, that's line AC and DF. And if you look here, line AC here forms one line, and they are in the same positions as lines DF. And then if you look at the single tick mark here, forming with its relative corresponding single tick mark on the other triangle, you can see that it's lines AB and DE. And as you can see here, A, B, and DE also have the same position. And finally, our last side length is going to be the double tick mark, and that's going to be CB, which is congruent to EF. And as you can see here, CB is in the same position and relative position as FE. So CB is in the same relative position as FE. All right, guys, so that'll be it for today's, all right, everyone, that'll be it for today's video. I hope you guys enjoyed. This has been the eCoreAcademy e-learning platform today. Please make sure to like and subscribe down below and hit that post notification bell. All of your support is very greatly appreciated, and I thank you all for getting us to 1,000 subscribers a couple of days back. That's a big milestone for us, and I hope you guys, keep enjoying this and keep sharing these videos, man. It's been a great help that you guys have been doing and the little community that we've formed. So I hope we can keep this going for a very long time. We enjoy making these videos, and I hope you enjoy watching these and getting a lot out of it. So also, on the side note, we have also finished our website at eCoreAcademy.org. So please go ahead and check that website out. We have full unlocked access to all of our YouTube videos, and we have organized course studies with all of these help pages, about pages, and basically technical support pages. And we organize all of our content into lists and course studies, organized course studies that go by course and subjects with integrated notes, quizzes, and worksheets that go along with each and every lesson and video. So this is a bonus to whatever you're looking here. It's completely free, and you can go make an account now. So please go ahead and do that now. And also, feel free to email us at eCoreAcademy@gmail.com. That's also on our website if you need any questions there as well. We have a phone number there if you need to call us, and we have an address there if you need to mail us. But our email is always available at eCoreAcademy@gmail.com. And please check out all of our other socials, which is in the description box below. We have all of our links there as well. So that's Facebook, Twitter, and Instagram. Check out what kind of content we have there. Our little unique posts, our little side trips that we have outside of just our just outside of our curriculum videos. So go check that out, and share all of our videos if you want to through our mediums of our social media pages. So I hope you guys enjoyed this video. It's been AJay Raj, and I will see you guys in the next one. Peace.